The journey of a rideshare program has been evolving since 1965, when Amsterdam offered and placed free white bikes, accessible throughout the city for public use. The honor system platform of this program, however, quickly proved that while the idea was helpful to commuters, the associated costs and risks of theft outweighed the benefits. Since then, the concept has evolved and has turned into an opportunity to provide alternative transportation for metropolitan areas for profit. The once free shared bikes became monitored with coin and then credit card deposits at specific return locations. And eventually GPS allowed the program to expand without docking stations to allow the bicycles to be picked up and dropped off at any location. As technology has further advanced and demand for these types of ride offerings has increased, the introduction of dockless scooters have entered the market. Today, we will be discussing the potential for profitability in the newest emergent of the rideshare program, dockless electric scooters. By doing both descriptive and inferential statistical analysis of a sample of bike share data collected from Washington, D.C., as well as data collected from additional industry research, we can describe what we found through our analyses and then make guided assumptions based on those trends that the data show us to determine if this industry is a viable investment opportunity. In statistical analysis, we are either accepting a null hypothesis or prediction of what data will tell us about a population of some sort, in our case related to the electric scooter share program, or rejecting it and thus accepting an alternative. For the purposes of our presentation analyses, we are testing two null hypotheses with our data to answer our objective of determining if rentable electric scooters are a profitable long-term investment opportunity. The first hypothesis we are attempting to prove is that electric scooter rentals are not a profitable form of investment opportunity. Our second null hypothesis is that seasonal and/or extreme weather do make a significant difference in the use of scooters. The flow of today's discussion will include a brief industry overview, SPSS and research data analysis, operational costs of a typical shared scooter program, the potential revenue opportunities, and a profitability analysis, as well as some obstacles an investor may face, such as demographic and regulatory factors. We will then provide the conclusion of our data findings in order to be able to provide both domestic and global expansion recommendations. So what exactly can affect rider usage of a scooter share program? What is the target customer? Can something like this platform be profitable? And if yes, where can or should this type of program be implemented in order to be successful? That is a story we are extrapolating from our guide, best known as data. It is through the analysis of the relationships between each tested variable that we can determine the answer to these questions, make data correlations, and make the best decision we can from what it shows. Some of our variables include user type, climate, including both temperature and weather, the number of bikes in inventory, the frequency and length of a typical paid trip, and mode of use. While performing our tests, we must be mindful that some of our data may be unusual or of concern. For example, one of our main concerns is that the SPSS data sample provided may not be enough to accurately represent the national or global populations. Does our data set provide every type of weather that may impact different parts of the globe? Do our sample results skew from the actual population? These are the types of obstacles we may need to overcome, and that is precisely why descriptive statistics aren't the only form of testing we must perform. We will also show you our research to include other factors of impact on the scooter share program. Information on operation, maintenance and replacement, and current safety regulation roadblocks will also be tested in order to provide as much data as possible to more accurately test our hypothesis and achieve our objective. The intended purpose of an electric scooter share program is to provide short distance or last mile transportation in dense metropolitan areas. Trips such as connecting with public transportation, traveling to or from work or school, enjoying dining or some shopping, or visiting places too far to walk yet too close for a car ride. Another theme we consistently came across through our review is scooters are also a fun way to make the trip. Our data sample identifies two types of users, registered and casual riders. Further, outside supported, independently researched supporting data breaks these users down into groups of commuters, tourists, and membership subscribers. One of the first analyses we will explain today is an interesting relationship between weather and the number of users of a scooter share program in Louisville, Kentucky, and the bike share program in Washington, D.C. We have pulled from the data the top 10 highest number of trips taken per day, and here's what we learned. We can see that the total number of rides in the bike share program greatly outnumber those of scooter rides. Most likely it's because the bike share program has been around longer than the scooter share program. The peak users of the bike program was 8,714, while the scooters show a peak of just 3,025. This data shows us that ridership may not be affected by the day of the week. Both weekdays and weekends are included in the list. Overall, the Louisville mean trip time was 19.581 minutes, and the DC mean trip time was 21.132 minutes. Does this maybe tell us that users have the intentions of commuting rather than a touristy meander around the city? Perhaps, but as we pointed out, we have to be aware of misleading correlations within our data. We need more information. It may also tell us that scooters are simply a faster way to get from point A to B, so it results in a shorter ride. We also see that all of the top 10 days in Louisville were in the spring, while the rides in DC were spread throughout spring, summer, and fall. The time frame of these days may correlate with temperature and weather, but we cannot make that determination from this data set alone. Interestingly, the third highest daily usage in Louisville occurred when 1.19 inches of rain fell. Again, maybe this is telling us that our riders have intentional purpose when using the scooters. I don't know about you, but if I needed to get to work or school in the rain and a scooter could get me there faster than walking, I would take advantage of it. In short, what this data shows us is that climate appears to affect usage of a shared program, and that the data is beginning to support our hypothesis that the greatest portion of user type is a commuter. During further analysis of weather data, specifically in a linear regression to plot our data curve, we can see that climatic factors are statistically significant, and that there is a positive relationship between temperature and the number of trips or uses per month. The graph shows a drop in usage during the colder months of the year when the temperature also decreases. We do, however, see a smaller variance in Louisville than DC, indicated within the slope of our graph for that data. Drawing from these tests, we can predict that a more temperate climate may have less variance in total monthly uses. In other words, either being too hot or being too cold is correlated to ridership use. But since correlation does not necessarily indicate causation, we will continue to perform more analytics. When the effects of our independent variable is not constant, we can run a curvilinear regression instead of a simple linear regression to represent the relationship between our two variables, frequency and mean drip duration as seen here, as a curved line. The top graph shows that from August through November, our frequency of uses was greater than the mean. Beginning in the colder months, December through March, frequency is less than the mean until it begins to climb again in April. From the pattern in the scatter plot of frequency by date, we can again make a prediction of pattern, that we will see a decrease of frequency through July of this year to follow the same pattern in August of this year as in 2018. The data for trip duration also indicates that shorter rides are taken during the months with typically colder temperatures. Most likely, we can infer that this is because uses are aligned with need rather than leisure. The bottom two graphs on this slide indicate that on a per diem basis, use frequency is highest on weekend days. Daily trip duration shows less variance, but commuters take shorter trips because they are specifically traveling from point A, perhaps the bus stop, to point B, maybe the subway line they need. Weekend user data show a trend of more non-registered users that are more likely taking a ride for fun without a specific timetable to reach their destination. Using the data sample from the Washington, D.C. bike share program, we see strong positive growth year over year of the total bike shared. Assuming that the trend continues, we can predict that there is more opportunity for rideshare platforms. But how can we determine whether or not the observed differences in the means of the data are large enough to allow us to accept or reject our hypothesis? Further analyzing the total number of bikes provided across the 2 years of the dataset, We observe the year-over-year increase in the amount of bikes. ANOVA, or analysis of variance, is a test we can run to determine if weather is a dependent variable in the total number of bikes. The Pearson coefficient tells us how strong the correlation of the variables is. The closer it is to 1, the stronger the correlation. We can see that the total bikes, our value positive, is 1, which indicates a very strong positive association between weather and total bikes. Actually, that's the highest correlation we can see. For casual riders, we see a value of 0.673 and registered users as 0.946, both also indicating statistical significance and proving that weather is in fact a dependent variable of total bikes. Looking at our descriptive statistics of the test shows us that registered users make up over 81% of users. We can also observe the most significant growth in registered users, demonstrating that the growth in users is with riders that intend to take frequent rides. How can we make this observation? The data here shows why we're able to make that observation, that the biggest growth is by users that intend to take frequent rides. Why? Because this data shows that the biggest percentage of riders is commuters riding to public transportation. 39% of users in major urban markets reported using Lime to travel to or from work, school, or appointments during their most recent trip. In addition, 27% of users in major urban markets reported using Lime to connect to or from public transit during their most recent trip. And 20% of users in major urban markets registered using Lime to travel to or from a restaurant or shopping destination during their most recent trip. In our data analyses, we looked at factors that can affect ridership of scooters and learned that temperature is a dependent variable on users, that the user group with the greatest increase of uses is members, and that the most intended use of a scooter is for commuting. We've run multiple analyses on our data to see if we can determine relationships between variables. But how do we determine if an electric scooter share program can be profitable? Can we determine the profitability potential? We have to examine the associated cost to calculate if revenue is greater than cost. The lifespan of a scooter is a critical determinant in the overall costs of operation. The less often the unit needs to be replaced allows for less overhead and the potential for more profit. Currently, the average total production cost of one scooter is $551, but there are new technological innovations being piloted right now that have the potential to lower that cost to as little as $360. In addition to the initial production costs, we calculated that the average daily unit operational cost is $9.29. We're getting closer to testing our hypothesis, but we still need to know daily revenue to compare with costs to determine profitability potential. When we extract income values from our data and consider average daily trips, distance, speed, and time to calculate cost per minute, and then add the initial ride fee, we can project daily potential earnings at $16.06. Now that we have our earnings potential and daily operational costs, we can now calculate how many average daily rides would be our break-even and profit-generating points. Since our average daily unit costs are $9.29 and our daily earnings potential is $16.06, we can determine that our daily gross margin is $6.77. This means that each scooter can earn only $3.18 daily to break even with the obvious associated operational costs. While our analysis provided us with preliminary data to make estimations about the profitability potential of a shared scooter program, there are still other factors an interested investor would have to consider. For example, at what quantity would there be a curvilinear relationship between inventory and uses? What is the right amount of scooters to have in inventory to be able to supply enough but not have an overabundance? For consideration of the actual possibility of earning this daily amount per unit, let me share that in just 1 year providing service, Bird reported 10 million rides, and Lime reported a combined bike and scooter ride total of 11.5 million in 14 months. In addition, it's forecasted that the electric scooter market saturation is expected to reach $28.56 billion by the year 2025. Unfortunately for any investor, the daily operational costs are not the only cost to consider when surveying an investment opportunity. In addition to determining the right balance of inventory supply, in the rideshare industry, there are several regulatory considerations to make. Some cities temporarily ban the distribution and use of electric scooters until safety policies could be set as guidelines. Without users, no scooter business venture can earn any revenue, so the viability of the industry relies heavily on negotiations with municipalities. Both rideshare principals, Lime and Bird, have been named defendants in a class action legal suit, where claimants cite negligence of the companies as reason for both rider and pedestrian injury. Another cost that is out of the control of operations is the fee that cities are imposing on scooters. There are several obstacles that any scooter investor will have to take into consideration before making an investment decision. Ultimately, the relationships developed with the city governments in which the scooters operate are an important determinant of profitability potential. The rentable scooter market is profitable when reviewed on an annualized basis, and therefore a good potential investment opportunity. We do realize, however, that significant economic and regulatory headwinds remain that could reduce or even eliminate profitability over the long term. Safety and regulatory issues are having an impact on growth and expansion that may ultimately result in added operational costs and have already generated liability claims. Not all cities or regions are ideal for future growth opportunities, as we found that mean monthly temperature, driven by seasonality, is a factor in use rates. While some early entrants to the industry may maintain large market segments, new entrants are finding their way to the market almost daily, driving competition and keeping pricing as well as gross margins in check. Ridership is growing fastest among members versus non-members, and our data suggests that members are the most prolific users, utilizing scooters for short distance commutes such as to and from school, work, and public transportation, demonstrating that the market, especially in areas with major public transportation hubs, still has a lot of room to grow. Demographic and climatic characteristics are statistically significant factors in usage and adoption of rentable scooters. And as a result, not every area has a potential for long-term profitability. After a review of successful characteristics, we decided to put more emphasis on highly populated areas with good public transportation hubs for expansion opportunities. While many competitors in the scooter market have focused on temperate climates for growth and expansion, our data suggests that perhaps with the exception of the most extreme winter months, scooters can be used to generate profitable revenue almost year-round in regions with a dense public transportation system. We made this conclusion after considering the largest ridership group was commuters, using scooters as a mode of transportation to get to and from work or school. Headwinds that scooter companies initially face from cities and municipalities are falling due to the potential reduction of carbon emissions, traffic congestion, and overall public embrace of the alternative form of transportation that scooter usage can provide. In addition, design improvement opportunities exist, such as scooters with interchangeable batteries and a more cost-effective design, potentially reducing the largest operating cost. Opportunities also exist to better utilize inventory, thus increasing return of investment potential by moving units to areas that fit the most successful temperature profile throughout the seasons of the year. Our focus for expansion as a result will be in areas that do not necessarily attract significant competition, but do have fairly high concentrated populations and good public transportation. Think Washington, D.C. instead of San Diego. Potential North American cities to consider for saturation include Arlington, Virginia, St. Louis, Missouri, and Chicago, Illinois. International opportunities include Seoul, Tokyo, and Hong Kong. All of these cities have good public transportation, but not necessarily year-round ideal climatic conditions to maximize ridership in all months. Therefore, Part of our strategy would be to move inventory to more active areas during the slowest periods of the years. Then we can minimize idle inventory, maximize usage, and maximize profit.